Hello, everyone. We're from Madison High School, and my name's Jose.
I'm Ali.
And this is our project.
All right, so this is just our final product that we came up with at the end.
All right, so this is sort of 4 years in the making. Freshman year, we took an intro to engineering design class, which was mostly a 3D modeling class, and it had to do with just sort of an overview of the different types of engineering. Sophomore year was digital electronics, which was like computer and electrical.
And for junior year, it's mostly mechanical engineering. And it's where I guess our teacher creates obstacles in which we're tackling as a team, which prepares us for senior year, where we work on our own project.
So some early brainstorming ideas that we had for this project were.
So I had an idea that we should come up with something to help you when you lose your keys.
One of my ideas was to make an app to protect your kick in soccer. And another idea we had was a Madison High School app where we just had our schedule and like lay it out of school.
And I had an idea for an outdoor vacuum just to pick up leaves and just specks around the yard.
But overall, we decided we wanted to do something that would be relevant and help our school.
So since we wanted to make something for our school, we took a survey of teachers and students at the school. We identified a main problem and we brainstormed solutions to those. So one of the big problems that teachers had was trying to track the people going to ELT, which is like an after school like help session they have open, and then attendance and hall pass.
So all of us have student IDs that don't really get used for that much except for a bus pass. So they have that little Chimet sticker on the bottom right corner. But other than that, they have our name and a barcode with our student ID number. So our idea was to come up with some sort of barcode scanner that could scan the barcode on our student IDs to help track like where students are. So if they're coming to ELT, when they're leaving for hall passes and when they're coming back. Our first idea of how we would do it was to build our own barcode scanner kind of from scratch, but we bought a barcode scanner and took it apart to try to reverse engineer it, and it was way more complicated than we originally thought. So that didn't work.
And for our second idea was to purchase a barcode scanner and to implement our ideas, but it turned out to be really expensive.
And our third idea was to make a photo scanner where we would take a picture of it and then do everything that a barcode scanner would do. So there were three components of this project. The first component was coding, what I did.
And where to put the information to, which is Google Sheets.
And I worked on the hardware.
So the coding language we chose was Python, obviously. And so the way that we manipulated Google Sheets was with GSpread. The way that we controlled the camera was simple CV. Reading data was with PyBar and Tesseract OCR. And to control buttons, buzzers, and LED was with the GPIO pins on the Raspberry Pi itself. Other reasons we used Python was our mentor was proficient in it, and we used GitHub to save the code, which personally it was kind of confusing for me at first, but after a while it was pretty easy to use. So the first part, manipulating Google Sheets with GSpread. So basically with GSpread, you had to make a connection with Google Sheets, and you did that with a secret JSON file, which is like a little key that you can have. So first, in this first section of code, we wrote headers for the sheets, like for like the student's last name and the student's first name. So when they read it, it's like a table. And then the other part of it was that it gives timestamps in and out. So the first section on the left is when you're starting an entry. So it basically writes last name, first name, ID value, teacher, reason, and timestamp to that row. And then on the right is the finish hall pass entry function that basically just finishes the entry, and it just gives the timestamp and how long they have been out. The next section of it was controlling the camera with Pygame. So basically at first, this was a problem for us because there was a lag when you took another picture right after another. So basically, to fix it, we used simple CV. And basically with CV, we had just had to initialize the camera, then take the picture, and then saved it to a specific place. To read the data for the barcode, we use PyZbar and CV2. So CV2 reads the image and looks for text, and PyZbar decodes the string for the barcode. The next part was to read the name. So that's how we got the name off of the ID. And this, using Tesseract OCR, was a problem for us. The ID had to be very straight in the picture. And that was just a problem for us because it was really hard to reproduce in our code. So the way we fixed that was we used Google Vision with regular expressions. So all we had to do for Google Vision was to open the file, and then it would detect the text and we just had to work out extra words like on the ID. So here are two comparisons of the Tesseract OCR versus the Google Vision. In the barcode especially, there would be parts of the name in the barcode which came up as eyes for some reason, but in Google Vision, it was a lot more clear and easier to work with. And the fourth section was controlling buttons, LEDs, buzzer, and with GPIOs. So basically, we just searched up on the internet how to connect a red, green, blue LED, and we basically just did that with GPIOs, which is a general purpose input and output, and it's just a way to connect other things to the Pi with electronics. And this is the main part of our program. So on the main loop, we just had this loop running the whole time that kept running code over and over again that would say, take a picture. And if it found a ID in the picture, it would run the code on it. If it didn't, it would wait a second and run it again. The bottom is the main program, that other main program that we used, and we used a try and accept code on it.
And for where the information was going to go to, we were going to do attendance and extended learning time, but there was a lot of issues with it, so we just chose All Pass. This is how our sign in and sign out sheet looks like. And so you can see it has the student's name, the location, the date, and time in and time out. And basically, we're making this so we can ensure safety for our students and for it to be environmentally friendly, and just to monitor where the students are, and just to keep the hallways clear. And so we used Google Sheets. So just basically, it has the first and last name and the reason as to why they're leaving the classroom, and it basically tracks down with the ID. And so I also, sorry. So I also, so it highlights red when the student just passes 10 minutes. And this is the chart of how it's gonna look for when student passes time of 10 minutes.
Right, so basically this is what the teacher would see. They would just see this in a chart form, and they can see really easily, oh, if they're above the 10-minute time limit, that's allowed to be out of class. So the hardware piece was what I focused on. The main parts was the case for the camera and the Raspberry Pi, the wooden base in the ID holder. So how we managed our time in class is we planned what we were going to do at the beginning of every day. We wrote it on pieces of paper on the whiteboard and had little check-ins at the beginning of every class period.
And then we continue that with using sprints, which is a form of agile. And basically, like Ruby said, we would choose what we wanted to do for a week or two, and then we checked off at the beginning of each class and see how much we got done.
Sweet. So at the beginning, we had a couple sketches of what we wanted to get done. And so they're ordered by how feasible they were.
So for our first sketch, we wanted it to have buttons so we can take the photo, and just for a buzzer to indicate when students late, and also just to have 3 buttons, a red one, yellow one, and blue one is no green one. I'm sorry. So the red one's for attendance, the green one's for hall pass, and the yellow is for extended learning times, just to switch modes.
Sweet. So our second sketch was similar. Our idea was we were going to be able to switch between the 3 different modes, but we were wanting to add a keypad in case a student didn't have their ID with them. They could just type in their student ID number.
And our third sketch was just a major stretch goal. To build off the second one, it added an automatic sense to the ID, so when they just put it under there, it would read it for them instead of having to press a button to tell them that they were ready. And add a screen for user feedback, so whether what that was typing in, using that as keyboard, or just a screen for user feedback.
So our first prototype, the MadCam 1. The photo scanner case, I modeled it in Autodesk Inventor, which is software that we learned how to use in the freshman class. And so the idea was that it would have the camera on the bottom and the Raspberry Pi on top, and there would be sort of a shelf for the ID to be on under. So it just has to protect the Pi and the camera.
So equipment-wise, first we used a Raspberry Pi 3. And then we tried to use a Raspberry Pi Zero W, which is basically just good for the low cost. And it also had Wi-Fi capabilities. And it had one USB port for the camera, which is all we needed. But that showed to not have enough RAM or memory basically to load it. So we went back to the Raspberry Pi 3, which also had Wi-Fi capabilities, had 4 USB ports and an Ethernet cable, and it was just higher cost than Raspberry Pi. And then webcam-wise, we used a Fosmin webcam, which we use for its low cost and its ability to take still images.
So this is what MadCam 1 looked like when it was all put together. It had the photo case on top and the ID holder on the bottom. And then we've got a little simulation of what the camera was seeing. Our second prototype, MadCam 2. So I changed the case up a little bit. I tried to make it fit the Pi and the camera a lot better. So we have the top piece, which covers the Raspberry Pi 3, and then the bottom piece, which holds the camera. And it's just a lot smaller, so it uses less material to 3D print, and it takes up less space and just looks nicer. And it also has access to all of the different stuff on the Raspberry Pi. Instead of having a little shelf for the ID to sit in, we actually cut a rectangle into the base and added a lever so that you could set your ID in and then flip the lever and your ID would pop up.
And then one of our problems that we had with our prototypes was the glare from the classroom lights, since the ID is like laminated. So what we did to fix this was we put walls around our prototype on the sides and also on the top to fix the glare. Another problem we had with our prototypes was the TriMet symbol reading as an O for some reason. I don't know why. But the way we fixed that was just put a piece of paper over it, professionally, yes.
So after those changes, we have the MadCam 3, which is really similar to the MadCam 2. There's not many major changes. It's smaller, so it's more compact design. Has the case from the version 2, and it has the lever ID holder. Basically, it's just we took the stuff from the second one and made it into a clean, nice prototype.
And so these are the next steps if we have gotten more time. And so basically, I was going to use an RGB LED for it. Well, an RGB LED is basically the color blue, red, and green. And it's just basically just to see if the student is like on time and not. So yeah, and also so we were looking for a place to put all the old information into, so we decided off with a PDF file.
And then one of the problems that we brainstormed that would be a potential problem was if the Wi-Fi was down or the internet didn't reach the classroom. So one of our options that we brainstormed for this solution was an offline option. So basically, instead of writing to a Google Sheet, we would write to a Microsoft Excel file.
And then basically we wanted to add a screen, but we were thinking about an LCD display.
And if we had more time, we were also going to work on the keypad for if a student doesn't have their ID with them, they can just type in the number. So here we see our version 1, 2, and 3. You can see it got a lot smaller and a lot cleaner looking. So our goal is just to get the MadCam into more rooms in our school so that instead of using those sign in, sign out sheets that we saw at the beginning, it can be digitized. Any questions? Oh, wait.
The question was, how did you solve the glare in the third version?
Okay, so we basically had walls like just in the.
Basically, we decided that we're in charge of where it goes. So we can position it away from the light, because where we were practicing in our room was like directly under a fluorescent light. But if we were to put it in another room, we could choose where it goes. So it doesn't necessarily need to be right under a bright light. Because if we moved it to another area of our room, it wasn't really an issue.
I asked, what was your feedback from your stakeholders when you rolled this out?
All right, so in the middle of the project, we presented it to some teachers from our school, and they were actually really supportive. But of course, they had some ideas to make it better.
So we haven't presented the finished project yet back to those same teachers, but basically the feedback that they had in the middle was that they liked it, but they were the ones who suggested that we add reasons for being out, because one of their concerns was that like our whole idea for the hall pass would be that like, oh, you can see which kids are gone for more than 10 minutes, but they wanted to, like, every once in a while a teacher has an exception to that. So they wanted to be able to be like, oh, this person was gone for half an hour, but they're not in trouble. It was because they had a visit to the nurse or something like that. So that was one of the things that they said that we should add.
It's just basically just to help our students, just to like make sure there's a problem like with the teacher or something, or it's just something's going on at home, check in with them.
Yeah, but overall they liked the idea of not having to flip through pages and pages of sign in and sign out sheets. Well, we're graduating this year. So that actually, we thought about that, but it wasn't really our main concern.
So what was the hardest / most frustrating part of the project?
The coding. So yeah, it was. We also had to VNC into the Pi a lot to work on it, because there was no screen attached to the small computer, the Raspberry Pi. So we kept having to try to get into it, like using the IP address, and it was just so crazy. We had to fix it like every class, and it took half a class just to get into the Raspberry Pi.
At one point, I walked into the room and the Raspberry Pi was taped up on the wall to try to get a better Wi-Fi reception.
Question over here.
I couldn't tell. What did you end up doing? Were you reading the barcode or interpreting the characters in English?
We did both. So the barcode was just to help track like who's out, who's in. And then we also added the last name and the first name, which is also on the ID, for teachers to be able to search through. So say like, we noticed that this person is out consistently for like a half an hour. So, they can have a conversation with that student at that time.
Yeah, so it read the barcode to get the student ID number for like official stuff, and then we read the text of the name so that it was easier for the teachers.
Were those both through the same software piece, or were you combining the data from two different sources?
Used Google Vision for the text and then used the Pisy bar for the barcode.
Here, you want to just pick up
Hi. Oh, cool. So I'm wondering what you guys have done in the past with 3D printing, because it seemed like maybe it took a lot of trial and error, but it seemed like you kind of knew what you were doing. So like, what had you done in the past, and where did you go to do 3D printing?
Well, how long have we've had these 3D printers for a while. This was the year that I worked the most with them. There was a period where like from the second prototype to the third prototype probably took the longest just because our 3D printer wasn't working. But when it was working, it definitely was nice to be able to be like, make this thing on the computer, print it out. Oh no, I need to tweak this, print it out again. That was awesome.
We also had like 3 printers, and like all of them weren't working at the same time. So that was great. And they also got an opportunity to work with a resin. Is that what it's called?
I don't know what it
Okay, a resin 3D printer, which basically instead of printing plastic, it was some kind of resin.
Yeah, it was really cool. It smelled very bad.
And it was sticky. It was kind of weird.
So can I look at your code on GitHub? I find it.
Okay, yeah.
Apparently, we'll be posting a link after this. So, yes. We'll get back to you. Oh, Dad. Don't do it.
So what happens if you can read the barcode but you can't read the name? Or was there any kind of error checking that?
Yes, it said error across. But also with that try exception thing, it would try it, and if it didn't work, it would throw an exception, which we read it to a log file.
Yeah, so like it saved all the photos, right?
Yes, it saved all the photos that we did with, and then we could look back at those and see what's wrong with it.
That was in the next steps with the RGB LED. The idea was that like once we got that working, it would be like red until you put the ID in and it got a successful scan, and then it would change color to green. So there's no user feedback yet, but that's what we would be working on next.
It was maybe asked already, but is it like in full-time use in someone's classroom yet, or is it
So yeah, it has, well, kind of.
Not yet. We have had multiple testing periods where we left it in Miss Gray, our teacher's classroom, but it's not like consistently in like a third party's classroom yet.
One of the times we put it on, it worked for one of them and then stopped working. So yeah, it's a work in progress. How about that?
So what was the hardest bug you had to track down?
That glare thing took a minute.
Yeah, it took a while. Probably installing all of this stuff. That was a journey. It wouldn't work on Windows, and then we tried to do it directly on the Raspberry Pi, and yeah, it took a while.
Any other questions?
how did you? Is there any one thing like with this huge project? There's probably a million different rabbit trails you could go down and get lost on, and then end up at the end of the year without something that works, right? Do you have an example of one thing that you were like, so you did all this project management stuff where you like assessed if you're making progress? Do you have one thing where like, oh, it was really good that we did this because we stopped from, going down this rabbit trail or sort of thing? Maybe one example.
I sort of got stuck so we sort of opened up what used to be the shop area in our school, and I got kind of distracted trying to clean it. So having Ali and Jose like coming in and being like, have you built a thing yet? And me being like, no, but I got this vacuum. And accountability was good. It's really clean now though. I labeled the drawers. Someone asked me where the screwdriver was, and I just pointed. It was right in that drawer.
All right, well, thank you, Ruby, Jose, and Ali, for this presentation.